Negative 5 plus 18. This is just like a problem that we saw in the last lesson. I mean, before we took that screening test, but negative 5 plus 18. So, remember the first thing when we do addition with negatives like this is to figure out the sign of the answer first. Now, the 5 is negative, the 18 though is positive. They're opposite signs, and that's important to notice, because the sign of the answer will be the sign of the bigger number. And in this case, the bigger number is 18, which is positive, so then I know the sign of the answer will also be a positive. Okay, so I put the positive sign there. I wouldn't put it in as part of the answer when I put it into Canvas though, but I just put it there so I know the answer is a positive. Now, in addition to that, now that we know the sign of the answer, we now figure out the number part of the answer. All you do is take the big number. Since the signs are opposites, you take the big number, which is 18, and you subtract the small number, which is 5. If they were the same signs, if they were both negatives, of course we would keep the sign the same, but then we would add the two values. But these are opposite signs, so I'm subtracting. In the ones place value, 8 minus 5 is 3. And then I drop the 1 from the tens place value to make that positive 13. And so the answer, positive 13. Done. Here's our objective for today's lesson. I can subtract with positives and negative values. You will find, though, that today we won't actually ever subtract with negatives. We will only add with negatives. We'll show how to do that here in a second. But take 30 seconds and copy down this objective. So you will want to memorize these subtraction facts. That's because when the signs are opposites, remember, then we do some subtraction, just like we did on the bell work, right? But really, you should only be looking to go down to 0, I guess. If it's anything other than that, then maybe we'll use some keep, change, all right? But as long as you can subtract with values, I mean, you can go beyond this, but then maybe using fingers. But if you can memorize these, then you'll be in really good shape. Now this says subtraction as addition, which is important to know. And I believe, well, I don't know if we covered it yet, but it doesn't matter if we have or not because, well, that's what we're going to talk about here. So, change the operation and sign to addition when subtracting a negative. This is called, or what I like to call, keep, change, all right? This is not keep, change, flip, although it is similar. Keep, change is to change subtraction to addition because, as I said before, we never actually end up subtracting with negatives. We only add. So keep, change allows us to change the operation to addition through this process, okay? So this is only related to the signs, though. Keep, change only relates to signs. It will never change numbers, only their signs and operations too. So if we apply it here, keep, change, let's see if I can do that though. All right, there we go. Keep, change, right? So, in this problem, notice the A, I'd say this A is positive. It doesn't matter if it's positive or negative, though. It just keeps its sign positive. And then the second part here, change, refers to the operation. See how that's minus? It then changes into plus. And then the B, which was negative, it changes into a positive right there. See that? Now you'll notice, and some students prefer to do this, keep, change is just kind of a double stroke thing like that. So you just put a couple strokes on the two operations, the operation and the sign, and it is keep, changes too, okay? So that's how this becomes two numbers added together at this point. And again, just so everyone knows, again, the first number there, A, whatever number it is, sometimes it could be negative, but if it is, it keeps the negative sign too. So as long as you understand this keep, change business, you will always be changing subtraction into addition because then we don't have to memorize lots of extra rules or think, well, is it going beyond 0 or anything like that. We just apply everything that we learned in 1.1, which was addition of integers. So let's see if we can apply this. Okay, so negative 31 minus negative 6. And I'll make this a little bigger, make it more convenient. And then, what do we got? Well, this is minus with a negative. I don't want to do minus with negative. So I'm going to change it to addition. How are we going to do that? Keep, change. There we go, change. Right here like this. It's not quite lined up. That works. Keep, change. All right? Keep, change tells us that we would keep this negative 31, negative 31. Again, keep change. It will not change the numerical values, but only the signs. And then I got some change right here, which will change this minus into plus. And then also we got some change, which will be for this negative 6 right there. It will change into positive 6. All right, so then we are looking at a problem similar to what we had seen from 1.1. These two signs are opposite. In fact, this is very similar to the belt work that we saw. These two signs are opposite. The 31 is negative, the 6 is positive. So which of the two is bigger? 31 is bigger and it is negative. So I know then that my answer is a negative. So there's my negative sign. Now, since the signs are opposites, I will also take the big number, 31, and I will subtract the small number, 6. 31 minus 6. And so I'm stacking this, and I'll have to use some borrowing. Not everyone has to do it. Like, you could do that in your head, but the 1 is too small to take away 6, so I make it 11 by borrowing from the 3 right there. Right, so that's there's 1 of the 3 and then 2 parts of the 3. 3, that's 30. It's just I split it up. And then I got 11 minus 6, which is, you can use fingers, and it shouldn't be something you're ashamed of, by the way, but 11, and this is subtraction. So 11, 10, 9, 8, 7, 6, 5. Using my fingers, I see that 11 minus 6 is 5, and then just drop the 2, 25. Now the answer is not 25, it is negative 25. Remember our sign over there? So that would be our final answer here, negative 25. Now, just in case I haven't mentioned this, I don't write this stuff up here on the board for your entertainment, okay? And it may be entertaining, which would be really weird. But it's not for your entertainment. It's for you to write this stuff down as well, okay? And then write any other notes that you may have in this. So if I write it on the board, the expectation is that you do write it down. And that way when your parents are like, hey, why is my student not understanding this? And I look at your notes, you haven't written jack squat, then, well, you can expect to learn jack squat, okay? So you should be writing this stuff down, though. Here we go. Negative 3 minus negative 3. Now, there was a rule, hopefully you learned it in elementary, not that elementary teachers teach math so accurate all the time, but in any case, you could find this answer pretty quick, but I'm going to apply what we've learned today, and that is keep, change, all right? So let's see if I can do this right. Keep, change. Maybe that's kind of big. Whatever. So let's take this and just kind of, that works. All right, keep, change. So that first number 3, it will keep its sign negative. Then I will go to the minus here, and I will change it into addition. And then I will take this negative 3 and change it into a positive 3. Negative 3 plus positive 3 now. And, well, this, when we combine here, the signs are opposites, but they're equal opposites. And hopefully that kind of helps you realize that the answer here is going to be 0. But if the two values are the same and you're adding, if the two signs are opposites and we're adding, we usually end up with 0 if they're the same value. Of course, you could have just done this regularly and said, well, they're opposite signs, so you take the big number minus the small one. Which one's bigger? I don't care. 3 minus 3 is 0, though, so you get the same answer either way. All right, here's another one for us. 21 minus negative 8. So once again, let's see if we can put in some keep, change on this. There we go. That seems to work. Okay, so the first value is 21. It's positive, so it will keep its positive sign. Then I will change this operation from minus into plus. And remember, we only use keep, change to change the operation to addition, so that we only have to remember one set of rules for the operation. So that's going to change that into plus. And then I will also change this negative 8 into a positive 8. Positive 8 right there, okay? In fact, some of you just like to see that as 21 plus 8 because it is the same. 21 plus 8, hey, no problem. We can even stack and add that if you need to. Shouldn't be ashamed of that. And the ones place value, 1 plus 8 is 8. 9. And then drop a 2, 29. Boom. 29. Final answer, done. So I do expect that to happen from time to time. You'll see by changing this into addition, it just becomes a positive plus a positive. That's old-fashioned addition, and hopefully you should be able to do that by now. If by chance you were ever to see like just a regular old-fashioned subtraction problem, you would not need to use keep, change. That's only when we're dealing with really negatives or if we're taking away more than we have. We'll get to that. Here's this problem. We got negative 8 minus negative 17. You try this one. Try this one out. Take 1 minute, try it out, then we'll go over it as a class. But the idea here is that you actually do try it out, okay? 1 minute. Let's go ahead and go over this, okay? Well, let's use some old-fashioned keep, change on this because it's subtraction with negatives, and we don't want subtraction with negatives, only addition. So we're going to keep this 8 negative, keep it negative, and then just as we've seen before, I'm going to change this operation from minus into plus. And then I will also change this minus or negative here into then a positive 17. Okay, so I end up with negative 8 plus 17, positive 17. And the two signs are now opposites. The 8 is negative and the 17 is positive. So I'm looking to add here. And so I want to figure out the sign of my answer, which is going to take the sign of the bigger number, which is 17. So I know the answer here will also be a positive value. Okay, so that's the sign. Now the numerical part, take the big number, 17, and subtract the small number, 8. And again, you can use fingers on this. 17 minus 8, so 17, 16, 15, 14, 13, 12, 11, 10, 9. That's 8 fingers up, which means that 17 minus 8 is 9. Positive 9 for this one. Of course, in Canvas, when you're entering this for your assignment, you would not put the positive sign. It's just 9. That's all you'd have to do on that. All right, subtraction as addition. Remember, sometimes we may just see a number subtracted from another. If the first number is bigger, as we've seen in the past, you know, like, hey, 10 minus 3, you don't need keep, change for this. You just know that 10 minus 3 is 7. That's fine. But if you were to switch these around, maybe this is 10 minus 30. Okay, you should probably use some keep, change on this. Because now you're taking away more than you have, right? It's like saying, well, you got 10 pencils and I stole 30. Not that I should. I took 30. Now that still sounds bad. You have 10 pencils, but you want to give away 30. Well, you don't have enough to take away that. Okay, so that you use keep, change. So that's what this is saying down here. With a minus b right there. Yeah, keep, change, right? So let's bring this down. Go and keep, change. And see how the a is, it's whatever the sign is of a, it just keeps its sign. And then you change this minus into plus. And then you change, that would be considered a positive value there. Well, now it's negative right there, okay? So keep, change will change any subtraction problem into addition. We do not use keep, change with multiplication or division, okay? But again, like it says down here at the bottom, we change these into addition, so we only have to remember one set of rules, and that would be the rules for addition. There are different ways to do this, yes, but if you can just get the algorithm down, then you can do any subtraction problem with negatives by changing it into addition problems, all right? So let's do it. There we go. It's a nice problem. Negative 9 minus 2. Okay, now let's do some keep, change action on this one. So we're going to keep that 9. We're going to keep it negative. But then I will change. I'm going to change the minus into plus. Now this is important for you to notice. The 2 right now is positive. So when I go to change it, I have to change the positive into a negative 2. Now, I like to put parentheses around that so we don't have to get that mixed up with plus minus. Would it be required? No, as long as you don't get it mixed up too, then you wouldn't necessarily have to, okay? But now I'm ready to add these two together. And the signs match. They are both negatives, which means that the answer will automatically be a negative. And then, that's the sign of the answer. It's a negative. But then, you're going to take both numbers, 9 and 2. Since the signs match, we add the two numbers together. 9 plus 2 is 11. And then we attach it to the sign negative to make it negative 11. That's it. Now do be careful on these because when we took the quiz last time, when we saw a problem like this one, the one with addition, some people they got 11 perhaps like a problem like this one, but they forgot the negative sign on that, okay? Or some people were just doing 9 minus 2, which would be 7, and that's not good either, okay? Because when the signs match, we got to add the numbers, but the sign stays the same for the answer. 6 minus 14. Yeah, we can do this one too. And, as usual, keep, change, change. Why are we using keep, change, change? Because I don't want to subtract. I would rather add. Now, if it was 14 minus 6, I wouldn't need to use keep, change, change. I could just use regular subtraction, but it's 6 minus 14, which is different. And some of you would say, well, you're taking away more than you have, so the answer is a negative. Okay, that's fine. And if you know that, that's fine too, all right? But I'm going to use keep, change, change just like we've been doing, all right? So I'm going to keep the 6, which is positive right now. I'm going to keep it as a positive 6. So there's a positive 6 right there. But then I will change, right? There's the first change minus into plus. And then the 14, which is positive, I will also change it from plus, or positive rather, to negative. 14 with parentheses. Don't want to get that mixed up with plus minus. It's plus negative 14. Okay, well, hey, look, now I've got a positive 6 and a negative 14. They're opposite signs, so I do need to figure out the sign of my answer. Since the 14 is bigger and it is negative, the answer will also be a negative. Now take your big number, 14, and subtract the small number, 6. This will be the numerical part of the answer. 14 minus 6, again, you may have to use fingers on this one, that's fine. 14, 13, 12, 11, 10, 9, 8. So that would be 8 right there. Negative 8. All right, so we got negative 8. And I'm going to show this a different way, right? And I do hope it helps, although I can't guarantee that it will. But I'm going to use kind of like the tiles that we did from last time. So remember here that the 6, first of all, is positive right there, right? So what I would do is I would show 6 positives. There's a positive right there. And, well, I need 6 of them. So there's 1. Here's another one. There's 2. And then kind of trying to use the technology to make this go fast. So there's 2, 4, 6. 6 positives right there, okay? Now I'm looking at our addition problem, right? Because I'm comparing, I don't ever want to consider this with minus, only with addition. But then we have 14 of these negatives. Okay, well, let's write out 14 negatives then. So there's a 1, 2, 3, 4, 5, 6, 7. And you know what? I'll just double this right here like this, okay? So there's 14. You could count them if you want, but I don't know anyone that would. In any case, now, when I combine these, right, because it is addition of these two, remember a positive and a negative right there, that's, when I combine those, it ends up being a 0. So I did circle them, but that circle is not a circle, it's a 0. And then, yeah, that's a 0 right there, 0, 0, 0, 0. Lots of zeros. And then we see these 6 positives right here, some people would say they canceled out those negatives. It just zeros them out is what I'd consider. That's why we use subtraction right there, okay? So you think if this 6 was negative, you'd have 6 negatives right there. You would have combined all the negatives, just counted all the negatives. And that would have, of course, that changes the problem. But where they're opposites, that's why we do subtraction, because the subtraction indicates that we're ending with 0 pairs. And then what do we got left over? 1, 2, 3, 4, 5, 6, 7, 8 negatives. These are all negative. Negative 8, that's our final answer there, okay? So hopefully that helps you understand why we're subtracting, but this is only after we change the problem into an addition problem. Negative 3 minus 7. Now, do you necessarily need keep, change, change on this one? Some people say no, and if that's you, that's fine. But I'm going to stick with the same method that we've been using, so we don't have to worry about should we be, are we going to go in the negatives, is it more negative, or anything like that. Just going to keep, change, change. So I'm going to keep that 3 a negative. then, as we've done before, we're going to change the minus into a plus. So that becomes plus, and then that 7. Again, that 7 right now is considered positive, but I'm going to change it from positive into a negative. Negative 7 right there. Again, parentheses, so I don't want to get that plus minus thing confused. Plus negative 7, that's important to know. And now I am ready to combine these, because it's an addition problem. So we got both signs here are negatives. 3 is negative, 7 is negative, so the answer will also be a negative. Then take the two numbers, 3 and 7, just add them together. 3 plus 7 is 10. Of course, the answer is not 10, it's negative 10. Remember the negative sign that we saw from the two signs there? So it's negative 10 right there. I know these numbers are kind of big, but I think you can do it. Try this one out. Take 1 minute, try it out, then we'll go over it, okay? 1 minute, go. Hopefully that was enough time to work on it then. And just as a quick spoiler alert, you should have gotten negative 1,599, okay? Well, let's look at that and see how we get that. And for me, since I'm dealing with the negative here, minus, I would use keep, change, change on this, okay? So keep the negative 644, just keep it negative 644, keep, okay? And then I would change, I'm going to change this minus into a plus. So there we go, there's our plus. And then that 995, which is positive right now, I will change into a negative. So then it becomes a negative 955. There's keep, change, change. I'll put in parentheses. And now I have addition of two values that are negative. So remember, the first thing when we look at addition with negatives, figure out the sign of your answer first. And since both of these are negative, I know the answer is also a negative. Now, when we operate with the two values, since the two signs were the same, just take both numbers, 644 and also 955. Just add them together since the signs were the same. Remember, we're going to apply the negative to the answer once we get this sum. So in the ones place value, 4 plus 5 is 9. In the tens place value, 4 plus 5 is, still 9. And then 6 plus 9, and again, you can use fingers if you need to, but eventually you should get up to 15 right there, okay? So we end up with 1,599, but it's negative 1,599. So there's our objective. Now it says mastery quiz. I believe we have a mastery quiz on this lesson, but we take it at the beginning of class next time, okay? Which would, for us, be next Tuesday. But there's our objective. I can subtract with positive and negative values. You should be able to do that because, well, we did, I think 8 examples or something like that. Should be pretty good now.